In this video, I am going to share how a material can be magnetized by applying some external magnetic field. In this lecture, I will cover some important points that how an atom acts as a magnetic dipole, what happens to orientation of atoms in a substance when it is magnetized. This diagram shows that in an atom there is a nucleus around which electrons are revolving in circular orbits. Now electrons carry negative charge. As shown in this figure, a current can be supposed to flow in direction opposite to direction of motion of electrons. So this diagram shows that orbit of electrons can be treated as a current carrying loop. So as a whole atom behaves as a current carrying loop. And a current carrying loop behaves as a magnetic dipole, so we can say an atom of a material also acts as a magnetic dipole. One face of atom acts as north face and the other face acts as south face. As a result, an atom can be represented by an arrow having one side as north pole and the other tail side as south pole. When the material is not magnetized, then atoms inside the material are randomly oriented and they form closed chains. As shown in this figure, it is clear these chains may be made by two atoms shown by two arrows in opposite direction, and three atoms can also make a triangle shaped closed chain. Similarly, four atoms may form a square shaped closed chain. Similarly, five atoms may form pentagon shaped closed chain. All these diagrams show that magnetic moment of one atom is cancelling the other. As a result, total magnetic moment in each closed chain is zero. Thus, we can say net magnetic moment of the whole material which is not magnetized is equal to zero. When the material is magnetized by applying some external magnetic field, then all the atoms get oriented in the same direction, depending on the direction in which external magnetic field is applied. So this diagram shows that between these two red lines, magnetic moments of all the atoms cancel each other and we are left with north ends of all the atoms collected to right hand side of red line and south ends collected on the left hand side of the other red line. As a result, we can say net magnetic dipole moment of the magnetized material is not equal to zero. So this is clear from this diagram that one end of the magnetized material acts as south pole and the other end acts as north pole. So a magnetized material acts as a magnetic dipole. Thank you very much for watching this video. I hope all of you must have understood how atoms get oriented when a substance is magnetized. Thank you.